In this video, I'm just going to get you started with graphing radical functions. This particular radical function has a reflection across the x-axis. It has a vertical stretch by a factor of 3. It has a shift 1 unit to the right, and it has a shift 2 units up. I'm going to use what I know about number sense to fill out my table of values. So because this is a square root function, I know I'm interested in getting a radicand, or a number underneath here, that comes out to be a perfect square. So I'm thinking about 0, 1, 4, and 9 to be underneath the radical. If I plug in a positive 1, and I plug it in for x, 1 minus 1 is 0, that's going to be the first value I'm looking for. 1 minus 1 is 0. The square root of 0 is 0. 0 times negative 3 is 0. 0 plus 2 is 2. So I have the ordered pair 1, 2. If I want to aim to get a 1, I need to plug in a 2 for x, because 2 minus 1 is 1. That's going to take care of this value. 2 minus 1 is 1. The square root of 1 is 1. 1 times negative 3 is negative 3. Negative 3 plus 2 is negative 1. If I'm aiming to get a 4, I need to substitute a 5 in for x. 5 minus 1 is 4. The square root of 4 is 2. 2 times negative 3 is negative 6. Negative 6 plus 2 is negative 4. And then finally, that takes care of this one. If I'm aiming to get a 9, I need to substitute in 10, because 10 minus 1 is 9. When I take the square root of 9, we get 3. 3 times negative 3 is negative 9. Negative 9 plus 2 is negative 7. Then I'm going to be able to plot these points on my graph. I'm going to plot 1, 2, 2, negative 1, 5, 1, 2, 3, 4, 5, negative 4, and 10, negative 7. And if I connect from the endpoint on, it needs to be accurate to the edge of the coordinate plane, including an arrow. This last example, I'm not going to completely graph it, but I do want to go over how you set up your table of values for a cube root function. For a cube root function, I'm still going to use number sense to figure out what values I want to plug in for x. But now, instead of aiming to have a perfect square as the radicand, or underneath the radical for this whole part, I'm going to be aiming to have perfect cubes. So my goal is to get negative 8, negative 1, 0, 1, and 8 underneath the radical. If I start with negative 8, I'm going to need to plug in a negative 10, because when I add 2 to negative 10, I get that negative 8. I cannot subtract 1 before I take the cube root. Taking the cube root is an exponent, and exponents come before that subtraction that's outside of the radical. So the cube root of negative 8 is negative 2. Negative 2 minus 1 is negative 3. That takes care of this one. The next point I'm aiming for is negative 1. I can substitute in a negative 3. When I evaluate, I get negative 1 underneath the radical. The cube root of negative 1 is negative 1. When I subtract 1, I get negative 2. I can substitute in a negative 2, a negative 1, and a positive 6 for the remaining values in order to get 0, 1, and 8 underneath the radical. When I do that, my y values should be negative 1, 0, and 1. From here, you can just plot these points on the grid, make sure that you have arrows on both sides because it's a cube root function, and you're finished.